everything. We were able to get shots from the air and everything, so it worked out well. Found out that taking pictures is nice, but everybody takes pictures. So we stepped it up. Basically, we're FAA drone certified pilots. We're certified in flight mastery. We're certified in drone 3D mapping and modeling. We went to a course for a week. It took mapping and modeling. We have hundreds of hours flying different drones, and the one back here is our latest acquisition that does basically infrared scanning and mapping, and it has a 30 times camera on it. So basically, John owns his own IT company, and he helps me with the IT stuff because he's a lot smarter with it than I am. So
and a couple of my IT customers are here today, so it's good to see you guys.
Yeah, there you go. There you go. So basically, the bottom line is we're going to show you a lot of things with drones in construction. You're going to find out that a lot of people can go out and take pictures, which is beautiful, video, which is beautiful. But when you want to go to the next levels, the next steps of what can a drone do for you in construction, we're going to be able to show you this. And if you have any questions later, please don't hesitate to ask. So without further ado,
so here's the disclaimer. Programs registered with AIACS for continuing professional education. As such, does not include content that may be deemed construed or approval endorsement by AIA or any material construction. So drones can be used in addition to just photography. You can do project planning, permanent record of installation, where after a project is built, you can gather data that measures, concrete foundations, where the building is, progression report monitoring. One example of this is the large warehouse that they're building for Amazon. That's such a huge project that to try to even keep tabs on what's been built and what still needs to be poured in terms of like concrete footers and things like that, you could easily use a drone to gather data to be able to measure the progress and keep all the different subs.
Right. Plus on that, on the progression, we're able to go out and set up the drone to take the exact GCP or GPS site, so we can fly a site as you're building it up and get the same exact coordinates every time. So when you're building your site up, you can end up with a 6 months or a year or 2 months by taking pictures every week, every month. And then when you're all done, you've got the same exact shots, which is very cool. And again, that records your monitoring and record of installation as the job goes.
Linear calculations, when you create a 3D model, you can use it for measuring. Based on the parameters of how accurate the model is, it can be down to a fraction of an inch. OSHA compliance, stockpile management, volumetric calculations, which will show you a little bit of that. Cut and fill volumes, which is exciting because there's really not a great method to be able to calculate dirt piles and holes in the ground. So this offers a huge opportunity for that.
And as we get started, if you have questions, feel free to ask them now, because there's going to be so much here.
Yeah, I mean, we're going to be covering a lot of just overview scope stuff, not like super in-depth, but a huge amount of topics. So here's an example of a volumetric measurement report that we did on a construction site in the city. And basically, after you generate a 3D model, you can go through and calculate, dirt piles that they can use for planning out the site work. So this is just a couple examples of that. In addition to doing 3D modeling, you can do building inspections, roof inspections, infrared. Agriculture is a huge thing because you can use some of the infrared features to track plant growth, watering, things of that nature, insurance inspections, emergency response, that's a huge one. Some of the infrared applications, you could actually put a filter on for search and rescue to try to find a heat signature for someone that might be missing.
And they use this drone a lot to
Yeah.
do that type of thing.
RF frequency surveys using some high-tech instruments where they can lay out different cell tower areas, movie location scouting, and mining, where if you've got strip mines, you can monitor and manage and report the different progress of where different parts of your mine are at.
Can you show them that 3D site?
Oh yeah, we'll get to that. The
Okay.
engineering and inspection, so site surveys, linear distance measurements, we talked about that, permanent record of installation. That's, basically you're getting a snapshot after the project is complete. So some of more of the topo stuff would be like watershed mapping, floodplain mapping, erosion control, landslide mapping. They also use this for fault mapping. And again, these aren't things that we do. This is just a broad overview of capabilities that some people might not be aware of that you can do with a drone. So surveying is a pretty good one. Surveying, the data would actually be collected using a drone, but the processing would actually have to be done by a certified surveyor. There are some surveyors that are starting to work with drones and add that to supplement their processes that they already use. So basically, one of the main things when you're creating a 3D model, you're using a method called photogrammetry. And so photogrammetry is using images to try to determine the shapes of objects and measurements off of that. And it's actually been around a lot longer than you might know. So there's photogrammetry that's been done in the early 1800s in Europe, which surprised me. And we've actually run into a couple of people recently that took photogrammetry in college and did it by hand using, pencil and paper and just an old school method.
Yeah, so they would actually take the photos from a plane and then they would lay it out on their desk like we did in the old days. And you'd take a photo and you tape it, put it together, and that was their photogrammetry.
And it would take
back then.
a super long time.
Yeah, and it wouldn't be close to accurate.
But yeah, so it's using computers as, as with everything else, has done a huge amount of it speeds up the process. So different types of photogrammetry software is available. We're actually going to focus on one that we've used. This is one of the more popular ones for unmanned aerial systems, called Pix4D. But the different kind of photogrammetry, there's aerial photogrammetry, which they do from planes. The state does a lot of that. They fly at about 1,000 feet. You could do close range photogrammetry, even from your phone. You could take pictures of statues and then use software to stitch that together to make 3D models. Unmanned aerial systems, which would basically be a drone, would be a small unmanned aerial system, and then satellites, which if you've used Google Earth.
Hold that for a second.
Yeah.
So that picture right there is the Walmart warehouse out by Marcy. That's a 100-acre site. That took us a whole day, 8 hours to fly that thing, using about 12 batteries. So to give you an idea, the size of that job and what that took to do, and what you're looking at is the model. You actually go with Pix4D and spin that model around to anything you want to look at and zoom in. So if you want to look at the concrete or you want to look at the roof or anything on the roof, you can zoom right up to it to see if you got issues or problems or things like that.
Yeah, the company that hired us to do this particular scan, they were interested in the concrete roadways because there's such a huge amount of trucks. So they needed a quick way to be able to scan a massive site like this to figure out what the condition of the surface is. We almost got ran over by trucks about 5 times.
Yeah.
but yeah, that's a huge site. That was pretty crazy to scan. So the drone mapping workflow, and a lot of this stuff I'm going to go quick because there's just a ton to cover. There's different ways to capture, you know, a quadcopter drone or a fixed wing aircraft. They use that a lot for larger sites. Some of the remote areas that, you know, on the poles in Alaska, if you have a huge amount of data, they use fixed wing. Once the data is gathered, then it goes into processing, which there's a couple of different ways, you know, desktop processing software, and then there are also cloud solutions, and different solutions have different advantages and disadvantages. The cloud rendering is quicker, but it's not as accurate. You can't really control some of the things. So after it's processed, you can go through and analyze and try to figure out what you're looking to get out of the data, and then that gets shared. So the actual process of photogrammetry is, most of the time, it's an automated flight where you set up software, and the software will take various pictures that overlap. And so based on the type of map that you're looking to get, you would change some of the parameters of the overlap, the angles, stuff like that. And then you basically set the drone out on an automated flight path to fly the mission and gather the data. So after that's done, this is actually a snapshot of the same warehouse. You see the representation of the pictures that we took are on top. And then those pictures are what the software uses to stitch together to create the 3D model. So the software, and this is not just Pix4D, all photogrammetry software, it'll go through and look for key points, which is something unique in each picture, and basically tag that as a unique, interesting point that it can use to identify. And then after it goes through all of the different photos, it'll find some that overlap, and then those get calculated as tie points. And so it's able to use the tie points and the key points to pretty much generate, you know, an idea that this is the same point from 2 different pictures, and then use that to calculate, you know, the distances and measurements. So once the software goes through and calculates that, the first thing it generates is a point cloud, which basically contains a specific point, you know, in 3D space of that exact, you know, feature. And the point cloud contains information. Each picture has metadata, which is the GPS, latitude, longitude, the angle of the camera. So it's able to use all of that data to figure out, you know, where that point is in 3D space. So you could also, there's LiDAR that's used as well. That's used with a lot of dense forest applications. It's super expensive. So after you get your point cloud, you can process it to create a 3D textured mesh, which basically fills in some of the gaps and gives you more of like a 3D object. The main purpose of this is really to give you something to visualize, you know, as a 3D object.
But you could, if you had GCPs, get accurate measurements on all the walls and things like that.
Oh yeah, yeah.
You
So
could also do on a building.
Yep. So with, you know, when you have a 3D object, I mean, there is value. You could actually measure different parts of the model. There's one company that we work with that they install awnings, and one issue that they found after they would produce these custom awnings for buildings is sometimes the measurements weren't as accurate because they couldn't get to something 30, 40 feet up on a building. Right? So by scanning the side of a building facade, they could use photogrammetry to measure the distance of windows, different features on the building, and then get more accurate measurements using a drone, you know, while they're standing on the ground from a building 50 feet up. So one really great construction feature with photogrammetry is a 2D orthomosaic, which if you see Google Earth, that's pretty much what you're looking at. And an orthomosaic, if you create a super accurate orthomosaic, you can import it into GIS software, and it contains all of the different location data where you could overlay it on a construction site and add layers from different progress shots and actually see, in the different layers, the building, and you can use it to check foundations to make sure that they were poured correctly. There's a bunch of things that you can use to catch problems ahead of time before, steel arrives on a job site or something, and you find out that the foundations weren't put, to specs as what the drawings show.
And that's happened many times in the steel industry. So that works out good to be able to get the pre-information. Saves a lot of people a lot of money and a lot of time.
So photo stitching, an orthomosaic is not really photo stitching, but it's easy to kind of think that if you took an object from a bunch of different photos and then just kind of cut them together, that's what a 2D orthomosaic is. But the main difference, this is just a really good representation, that it doesn't account for the different angles that you might have of one object from a couple of different angles. So a 2D orthomosaic takes everything into it factors everything when you're making the map. So it can be highly accurate, and it's all based on the different data that you put in, on whether you have a super highly accurate map or just something that's a 3D model for representation purposes. So to go off in addition to the 2D orthomosaic, you could also create some other files using photogrammetry or other outputs, like a digital surface model that shows everything on the site, including the structures. There's a digital terrain model, which will basically have just the terrain, minus any structures and trees and things. And then that gets processed further where you can actually create contour lines off of that. And so each picture, when you're going through and making a 3D model, the pictures, they all have different GPS data that gives information about where the objects on the ground are. And you can create a pretty decent accurate map, and it's relative accuracy, not absolute accuracy. So things on the map would be accurate to other things on the map, but to really get a truly accurate map, you would have to also factor in having ground control points. The good news is most construction sites, you're going to have ground control points that already exist.
Right, when you start a site, general contractor will normally lay a bunch of ground control points. So if you need a drone shot to go up and do a layout map, we can use the ground control points that are already there, and it gets you accuracy within a couple thousandths of an inch for a layout of a foundation, say.
So having ground, if you need something accurate that's used on a construction site, construction level, you definitely would have to have ground control points. There's a type of drone called an RTK, which is real-time kinetic correction. But still, and they claim that you don't need to have ground control points to really, the point of it is, if you want to have an accurate map, you do have to have some ground control points to kind of snap everything into place on the ground.
And which again, any construction site is always going to have that to start with. That's how they lay out a job. So.
But without ground control points, you could still make a nice 3D model for marketing, video fly-throughs, visual effects things. You can even 3D print your models. So if you ever wanted to have a little model of your house, you know, on your desk, there's some really, this is just the beginning of some really cool stuff that you can
Right.
do with modeling. So do you guys have any questions about photogrammetry or 3D models?
There's a lot to it. And if anybody has any questions later, we'll give contact information at the end. You can absolutely email us or call us. We'd be glad to answer any questions.
Okay, so the next thing, obviously, visual inspections. You know, photography is one thing, but with the proper equipment, you can use some, you know, high-level zoom cameras to get really good pictures to inspect things. It reduces risk. You don't have to build scaffolding and temporary structures. You know, it reduces your liability. Some of the wind sites, they have to climb the tower and actually rappel down the side of the tower, you know, to try to inspect the blades, and it takes hours.
Or use a crane. In our land, you had to go out with a crane and put a man basket on the end of a tip, and that would cost several thousands of dollars per day, where a drone might cost you several $100s per day. So that's an immense savings right there.
So here's an example of a 30x camera,
which is this camera right there.
If you have a 30x camera, this is a shot you typically get from a drone, and then that's 3x, 6x, 12x, and that's 30x. So that's the same exact distance. So that's how far. I mean, it's really, really powerful to be able to get that kind of you know, detail from a shot that far away.
So you can get good shots without getting close to things.
Confined space, that's a huge thing. Some of these pharmaceutical companies have chemical storage vessels, and there's just, you know, some companies have areas that just are not safe for humans at all. And so occasionally they get inspected, but there's usually a huge amount of things that they have to do prior to that. They actually make confined space drones that go in these little hamster balls that they can kind of bounce around and protect the drone from impact. And for something like this, a drone doesn't have GPS because it has no line of sight of the sky. So it's, you know, that gets to be important to be able to you know, protect it from kind of flying around.
We used to do a lot of work up in Novellis where there was a ton of confined space in the furnaces, the tanks and things like that, down in the basement, where you always had to bring the heat down to 80 or 90 degrees with a human, and that was still too hot to go in there and have to wait 3-4 days. We can fly, you know, 110, 115 degrees inside of a confined space. You don't have to send anybody in there. You can do all the inspections. Same thing with a lot of tanks at Budweiser. They got a lot of beer tanks and things like that. Got to send people in to take a look with a flashlight what it is. This is the latest technology to be able to send people inside of tanks and furnaces and all that dangerous chemical stuff without ever sticking a head inside. So this is the latest technology, and this is going to be fantastic.
And again, this isn't what we do. We don't have one of these. I think these things are like, this particular one's like 20 grand, but this is just an overview of, you know, drone technology,
Exactly.
all the great things you can do. Infrared inspection. So if you have a flat roof,
And that's this camera right here.
yeah, if you have a flat roof that you have issues with leaks, which if you have a flat roof that's not a commercial building, that, you know, there's a chance that you might. If you use an infrared camera, you can actually see where the cold spots are, which will indicate pooling underneath the roof and show you where you have water that's going under the rubber barrier. So here's an infrared inspection. This is actually a picture from from the camera that we used a couple weeks ago as a test. This was a commercial building in Liverpool
Yeah, with a little bit of,
that's been having
damage.
some water issues. So solar farms, if you have solar farms, some of them are massive. And really one of the only ways you can find out if you have a bad cell is one of the cells will be running a lot hotter than some of the other ones. And it sticks out pretty clearly. So you can use this to quickly identify bad cells, bad panels, and get them replaced to minimize the loss of generation. Of course, you can also use infrared for heat loss on roofs and buildings, walls.
there's a great example of some heat loss right there. In the front facade of the house and the roof. You'd never know that without taking that shot where your energy losses are.
They use infrared a lot in electrical inspections. If you have a fitting or bushing or something that's loose, then it'll actually heat up if it's not making a tight fit. This part gets a little deep because you have to use any, I forget which, there's some FLIR certifications that you get when you go into this level of comparing the different temperature differences. But drones with infrared has proved to be a super efficient and quick way to be able to check lots of electrical equipment. So back to the visual inspection, here's a picture that we did. This is a surge tank in Potsdam that is about 300 feet tall. And one day they could tell after a severe windstorm that they had some damage on the roof, but they had issues trying to see how severe the damage was.
And again, the old days, they would call us up and say, bring up a crane with a bucket in it. And you'd have the crane on site for 2 or 3 days. It would cost you several thousands of dollars to get somebody up a couple hundred feet to be able to see what this damage is. And the drone, how long were you up there?
Or you'd have to run a full-scale helicopter,
Right.
and they could only get so close. So this was a long time ago. I think this was probably 8 years ago. So in this particular case, I met with the site owner and a roof contractor, and within 5 minutes, they knew the extent of the damage, what they had to do to fix it, what equipment they needed. It saved them a ton of time and a ton of money. But the cool thing was the surge tank. Basically, a hydroelectric dam. If the motor ever has to shut down, if the generator ever has to do an emergency shutdown, the water has to go somewhere. So it would get shot up to this tank 300 feet up, and just to hold the water, kind of like a circuit breaker. But this thing was over 120 years old, and it was just unbelievable. It actually had rivets back before they were even using nuts and bolts. So it was just, an incredible thing to see. And this particular drone, this was the first one we built. There wasn't any like turnkey, solutions that you could just buy off the shelf. So everything was a project. You started out with a helicopter, and then you had to build the landing gear and the platform and the telemetry system, and everything was just such a project to try to get it to run correctly. And in the very beginning, we didn't even have a first-person view camera. We just strap a GoPro to it and then go take a couple thousand pictures and hope you got something.
The other good thing with the IR camera on a water tank, you can go there and shoot the water tank, and it'll give you with the IR readings where the level of the water is. If you don't know where the level of the water is, because of the different heat signatures, it'll tell you what the level of water is in the tank.
Here's another surge tank. This one is east of Watertown. Again, this was they had some wind damage on the roof. So that was a great quick way to see what the significance of the damage was. Here's a wind turbine in a upstate New York wind farm, and apparently they had a windstorm and they came in the next day and the nose cone popped off. And so I was on site within a couple hours, and, you know, we said, well, that's crazy. Like, how often does this happen? And they're like, well, it happens a lot more often than I wish it did. The damage to, you know, originally the nose cone actually went down, 50-foot hill and rolled away. But, you know, from the ground and a pair of binoculars, it was really difficult for them to try to assess.
Yeah, this is about 300 feet in the air.
And you could see all the cables up in the top that just kind of, you know, all of the different control stuff that just got ripped out.
And again, this used to be a big crane, 300-ton crane with a basket on the tip, 2 or 3 days worth of work, tens of thousands of dollars to get up there and check that damage.
So this was cool because they, you know, within a couple hours, they were able to tell exactly what they were dealing with. They sent the information to the manufacturer of the turbine under warranty, repaired, and the damage was a lot worse than they thought that it was going to be. But without having pictures like that, they wouldn't really know. When the nose cone popped off, it actually impacted the blade, which, you know, that's at this point, I think the whole blade had to be replaced just because the amount of damage. You could see it's cracked right there. So, you know, blade inspections, a lot of these, well, wind farms, the larger ones, they have automated drones now that they could fly a drone, you know, completely by itself and take all the pictures and build a report. Some of these are actually using photogrammetry to do inspections on cell towers and wind turbines and things like that. So that's, you know, it's amazing the technology that's rapidly being developed. Bridge inspections, as you know, and, you know, especially in Syracuse, there's bridges need to be inspected. A lot of times they'll have a truck that drives over and there's this arm that comes down and a camera that goes under. You know, yeah. So there are instances a couple years ago. One of the companies out of Albany that we work with, there was a bridge that got impacted by a boat or a barge or something, and they weren't sure what the damage was. So they were able to use an M210 with a top-mounted camera, which is what's shown here.
Right.
And basically fly under and inspect the bridge, and you know, just stuff like this that's really tough to get to.
Yeah. See, with the camera on the top, you can inspect everything underneath, all the beams, the girders, all the connections, the bolts, anything like that with the camera on the top, and then you can put a camera on the bottom also. But that's so again, without having a guy come out with a truck that hangs over the side and 2 guys in the truck, 2 guys underneath, you can imagine what that costs, you know, based on, you know, the difference in the cost of this thing for a day.
Here's a crane in some city that had an issue a couple months ago. The issue in this particular case is that they weren't sure if they could safely get the crane down because they weren't sure what caused it to crash to begin with. So basically, you know, within a half hour, they had enough pictures on different components of the crane to determine where the point of failure was, that the hinges were safe, and that they could come up with a plan to lower the boom and get that down. So, you know, stuff like that, it's just helps with safety, and it's super efficient and quick. Some scaffolding. This is the building, the Verizon building. They used to have those microwave dishes on top. So they had some structural issues at the top of the building a couple years ago. They were removing that. So I wanted to throw that picture in. I thought that was good. Wind turbine parts. That's actually at a storage facility. And then here's on the left is the first drone I built close to 10 years ago, where it just had a GoPro, you know, tie wrap to the bottom, and everything was a project, and it you know, it was such a pain. And then to see just how unbelievable everything, you know, technology wise has gone to. The new drones now have ADS-B receivers and transmitters where you get you can get notifications if there's other aircraft in the area. As a warning system. The FAA's adding some regulations that have to do with remote ID, and there's a lot of things coming down the pipe, but that's basically, the amount of technology of, where everything's gone in 10 years is crazy. And then that's basically pretty much it. Does anyone have any questions?
Drones can do an awful lot of stuff, and it's just at the very, very, very beginning, infancy of
Yeah.
what drone technology is. Any
I didn't
questions?
see any deliveries. I didn't see any notice about deliveries.
Deliveries? Oh, wow. John, tell them about deliveries.
What deliveries?
Drone delivering things with.
Oh
drones.
yeah, no, you know what?
We didn't put that on there.
Okay, so I started putting this together, and there, I mean, there's so much that we had to figure out what to put it, because photogrammetry itself could be like a 3-hour thing. So drone deliveries, it's funny you mentioned. A couple of months ago, there's a company that reached out. They delivered COVID test kits off the roof of Upstate Hospital, and they hired us as pilots to participate in that because we have 107 Part 107 FAA certificates. So we actually got the opportunity to go on the top of an active helipad downtown Syracuse and fly a drone with a ballistic parachute system over the city using a special waiver that took them a year to get.
The first waiver
Where,
in the
where you
country.
could fly over people. And it was unbelievable. And we delivered COVID test kits.
So we did that. And we're
And-
doing, coming up in May, mid-May, we're doing some more flying of test things and
They haven't told
body
us
parts
what
and
it is.
stuff
No,
like
they
that.
haven't told us what it is yet, but I mean, it was, yeah, it was on the news.
We're hoping it's not body parts are flying. Oh, who knows?
Yeah, no, that would be a different waiver. But yeah, the drone delivery stuff, I mean, that's definitely coming. But the one that we were in, there's so many regulations with the FAA, like even to fly over a person or across the road that might have a car on it, it took a $10,000 parachute system that had a rocket in it. And it was just, they had to crash drones into windshields at the NTSB safety place for like 6 months to figure out what speed is safe to throw a drone through a windshield where it doesn't kill everyone, and then use that to calculate what the wind you could fly in. And it's, I mean, so that's still a ways away, but yeah, it's crazy. But they have done drone deliveries overseas with the FAA regulations being, without having the kind of regulations we have here. They've flown heart transplants and all kinds of things from one hospital to another several miles away, line of sight, and able to do it within like 5 minutes, where it might have taken half hour by car.
Speaking of the Part 107, are they back up and running yet with everything that's been going on with the COVID, the test centers?
You used to have to take a recurrent test after you got a 107, and they just actually did away with that. Now it's you have to watch a webinar from their website and take a test. But the actual 107 testing centers, I'm not sure if those are run by third-party companies. There's a couple that are in the area. I'm not sure if
I don't think
they're
they're
open yet.
I don't think they're open yet.
But
The new drone ID system in there is becoming effective in the next couple of weeks.
yeah, and that's causing an issue too, because the original requirement was that you had to have, an expensive drone identification system that added a lot of weight and complexity. And they've been revising it and making things more manageable and delaying it while they figure it out. But that's kind of been a mess too.
But within 2 years, everybody that wants to fly a drone anywhere, whether it's commercial or hobbyists, are gonna have to have an ID system, and the government's gonna know exactly where you're flying at every second. and that's the way it is.
The problem is just, you know, it takes a handful of some of these, you know, people that do ridiculous things that just ruin it for everybody.
Right.
You know, they had two people that they arrested flying at the Super Bowl. You
With
know?
licenses,
And it's, yeah,
and they both had
they
licenses.
both had 107 licenses, so
So they
you
knew
know,
better, they just
Yep.
didn't care.
Yep. So,
And again, if anybody wants to reach out, any questions or anything, our information's there. You can always reach out and we can answer any questions that you have.
Guys, to what detail or tolerances does the current equipment that you guys have give? Like if I were to shoot a building and we're going to be putting exterior wall panels in between existing structural steel members, what are the tolerances that you would be able to get to show me the size of the openings within a building, or if I was going to re-window it or whatever that may be?
without GCPs, it could be, I mean, you could be accurate within an inch or two. With GCPs, you could be down to,
Tenths of an inch,
yeah,
like a 1 or 2/10 of an inch.
yeah. One of the exercises we did when we took our drone mapping class is they had us measure a tape measure on the ground from a recreated accident site that they did with the NTSB. And we were able to measure from one end, from the tip of the measuring tape that was on the ground to the end. And we were within, I think it was like a tenth of it, like, was it a 16th of an inch?
No, it's like it's within a less than a tenth.
Yeah, it was.
So Andy, would you throw down a GCP to get that?
Yeah, I mean, it would be like, I'm just thinking an existing project.
Okay.
You know, if you
I
had.
mean, how close are you looking to get? Let me ask that. What's your tolerance? I mean, steel is normally a 1/4 inch anyway, right?
Correct, yeah. So
So
that's
would
what
you
we'd
use
be
something
looking
better
at
than
is,
a 1/4 inch?
yeah, well, we've had installations where, you measure it with a tape measure, but you're measuring the bottom of the beam at the concrete slab and you don't realize that the column actually is
yes.
curved on the way up through.
Yeah.
But I'm thinking with this technology, you may be able to see the tolerances and the variations in the actual members themselves.
You can. I've heard of people shooting rebar. They're getting rebar movements, all kinds of stuff. It's really, really cool. But so that's the difference. I'd say 1/4 inch, which is steel tolerance, with a without a GCP. And if you have a GCP, definitely within tenths of an inch. Be glad to try something for you, though.
Okay, any other questions or? Well, thanks for doing this. This is a really great program. I know I was definitely interested in
Thank you.
learning about all this stuff. It's really, really cool stuff, so.
That's where everything's going to. And again, if anybody wants to reach out later, we'd be glad to show you what we can do or answer any questions we have. We love it. We love the drone thing, and we've been doing it forever. John's been flying RC planes since he was just a little boy. So it's the next step for, what we're doing. So
Yeah, thank you, Dave. This was incredibly impressive. Thanks, John.
thanks, Ann.
Thank you.
I had no idea of your capabilities.
Yeah, we didn't either.
Oh,
I just came up with it.
No, that's the thing. Like I said, we do everything we showed you. We do some of that, and we are certified in mapping and things like that. But there are just so many things, like the working in confined spaces, thing like that. You can't go out and buy, $500,000 worth of stuff. We're trying to look at what's going on, but we wanted to go more steps above somebody going out and just getting a picture with the drone. Anybody can do that. So, you know what I mean? We're trying to be
Yes.
helpful. If we can, like what Andy said, can you come out and lay out a wall for me? Tell me where we are all the way up to Calma. We can definitely do that. That's the type of thing that's going to make things, wonderful rather than tape measure. And so that's the kind of thing we offer.
yeah, thank you. Thank you. This is
Thank you.
great.
Yeah, thanks for your time, guys.
Yep.
Thank
Thanks for
you.
having us.
Yeah, thank you.
Thanks, Dave. Thanks, John.
Thanks so much.
John and Dave.